Hello, my darlings. Okay, so today we're going to talk about related rates. In differential calculus, related rates problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. For instance, if you have a street light and you have a person running away, okay, we can do problems like that. We have a man fishing off a pier and he's reeling in the fish. These are all kinds of situations. Let's take a look at one. So the first one here, Phoebe is going east on Alamo Street, and you can see in the diagram, Phoebe's going here east on Alamo Street. She's walking in that direction at 40 feet per second. Meanwhile, Calvin is going south on Height Street at 30 feet per second. Phoebe wishes to determine whether the straight line distance between them is increasing or decreasing. So notice Phoebe's distance from the intersection is x, Calvin's distance from the intersection is y, and the straight line distance between them is z. So if x is Phoebe's distance from the intersection and y is Calvin's distance, write the rates we know. So dx dt would be the rate at which Phoebe is walking away from Alamo Street. This distance is getting bigger, it's increasing at 40 feet per second. Now, Calvin, on the other hand, is walking towards the intersection. This y is getting smaller, which means that dy dt is negative 30 feet per second. Okay, now if z is the straight line distance between Calvin and Phoebe, we want to know the rate at which that distance is changing, so we're looking for dz dt. That's what we're looking for. Okay, now to find the rate we want, we need an equation relating the variables in the known and wanted rates. So look at the picture. What equation can we use to relate x, y, and z? Well, that's a picture of a right triangle, which means we can use the Pythagorean theorem. So one side squared plus the other side squared equals the hypotenuse z squared. Now we're going to differentiate both sides of the equation. So I'm going to write the equation here again just so you can see it with me. And if we take the derivative of x squared with respect to t, that's 2x dx dt, because we want to know this rate as it's changing over time. That's why it's dt. Plus the derivative of y squared is 2y dy dt equals the derivative of z squared is 2z dz dt. Now something that might help us, if you notice there's a 2 in each term, we can divide out those 2's. And now we just have x dx dt plus y dy dt equals z dz dt. Okay, so now when Phoebe is 200 feet from the intersection, so x is 200 feet, Calvin, that's y, is 600 feet from the intersection, okay? And remember, we already know from back earlier in the problem that dx dt was 40 feet per second, and dy dt is negative 30 feet per second. We want to know dz dt, right? That's what we're looking for. So we're going to take this equation that we just had when we took the derivative, x dx dt plus y dy dt equals z dz dt, and we're going to plug in everything we know. Well, x is 200 times dx dt is 40 plus y is 600 times dy dt is negative 30 equals, I don't know what z is. I don't know what z is. However, if you remember, the equation that we had that related these variables was x squared plus y squared equals z squared. So that means that 200 squared plus 600 squared equals z squared, or z equals the square root of this. Now, you could go ahead and square these and add them up if you want. Do not take the square root and get a decimal. You are not allowed to round. Yes, on the AP exam, you're allowed to round every problem to 3 digits after the decimal, but only at the end of the problem. So my suggestion, don't even worry. Put in square root of 200 squared plus 600 squared. Then remember, we still have a dz dt here. Okay, so that means, let's see, we've got 8,000 minus 18,000. And if I want dz dt by itself, we're going to have to divide this by 200 squared plus 600 squared. Now you're going to go to your calculator, and you're going to carefully put that in your calculator. Let's see. So I'm going to open a fraction. I'm going to have 8,000 minus 18,000 over the square root of 200 squared plus 600 squared. And that's about negative 15.811. And our units on this would be feet per second. Now, what did they ask us? Remember, when we do these, we need to make sure we answer the question. At this time, is the straight line distance between them increasing or decreasing? Well, if this is negative, that means the distance is decreasing at a rate of 15.811 feet per second. Nice. Now, steps to solving related rates problems. Number 1, draw a diagram. Number 2, write the given information. Number 3, label the constants and variables. And number 4, indicate the desired information. Now, I'll be honest, all 4 of these can be done in different orders. The order may vary. The reason is I do those 4 steps as I read the problem. Okay, then you're going to relate the variables with an equation. You're going to differentiate implicitly. You're going to find the desired rate. You're going to answer the questions being asked. You're going to check your answer for reasonableness and be aware of units. Make sure, this one's really important, make sure you answer the question that's being asked. Make sure you check for units and reasonableness. If you're finding the velocity of a skydiver jumping out of a plane and your velocity is positive, something's wrong, because that means the skydiver is going up instead of down. Okay? Look and see if your answers make sense. Okay, next up is one of our cone problems. Water is flowing at the rate of 50 cubic meters per minute from a concrete conical reservoir. That means when it's coming out, that's the volume. Notice meters cubed per minute. That's dV dt. And since it's coming out of it, the rate of change is negative 50 cubic meters per minute from a concrete conical reservoir whose vertex is down. So we've got, looks like an ice cream cone here. Okay, and the water's coming out at this rate of negative 50 meters cubed per minute. Okay, now when we have this, we're also going to have a radius here, and we're going to have a height here. Okay, they also say that the base radius is 45 meters. So when full, this is 45 meters, and the height is 6 meters. Okay. Then they go on, isn't it nice? They tell us what the volume of the cone is with radius r and height h. Now, in part A, they want to know how fast the water level is falling when the water is 5 meters deep. So they're looking for the water level is h. So if they want to know how fast that's falling, we need to know dH dt when the height of the water is 5 meters. Okay, now remember the volume formula is pi over 3 r squared h. If we were to take the derivative of this, we would have a dV dt, which we know, that's okay. we would have a dH dt, which is okay, we're looking for that. We would also wind up with a dr dt. I do not know dr dt, therefore I can't have an r in my equation. But the nice thing about cones, if you look, as the water drops, see these little different triangles here? Each of these triangles is similar to the other, that the sides R and H are always in proportion. So R over H, when it's full, is 45 over 6. Okay, now 45 over 6, that's going to reduce to 15 over 2. Will make our lives a little simpler. Now I know that R is 15 halves times H. And we're going to take this and we're going to replace it in that volume formula. So this means that our volume is pi over 3 times R is 15 over 2H. And remember, we're squaring that radius times H. So now we know that our volume is, let's see, if I square 15, that's 225. I have pi, 2 squared is 4 times 3 is 12. And h squared times h is h cubed. There's my new volume formula with only the height. Now we should be ready. Actually, we could even simplify that because I'm pretty sure 3 goes in there, right? Wouldn't that be 75 pi over 4 h cubed? It's nice to have smaller numbers if we can. Now we're ready to take the derivative. So the derivative of v is dv dt. And we're going to take the derivative of this h. This constant's going to stay. But 3 times 75 is that 225 pi over 4 h, decrease the exponent by 1, times, what's the derivative of h? That's dh dt. Okay, now we get to plug in what we know. So now I'm going to plug in what I know. dv dt is negative 50 equals 225 pi over 4 times h is 5 squared, and I'm still looking for dh dt. So now I've got negative 50 equals 225 pi over 4 times 25 dh dt. Now I'm going to come up top here because I'm running out of space, but I'm going to divide both sides by this 25 because I know it's going to go in nicely. So I'm going to do that, and negative 50 divided by 25 is negative 2 equals, now I have 225 pi over 4 dh dt. Now in order to solve for dh dt, we're going to have to multiply both sides by the reciprocal, 4 over 225 pi. So that means that dh dt is 4 times negative 2 is negative 8 over 225 pi. Make sure that pi is in the denominator. And our units on the height are meters per, on time is minutes. Okay. Or if you wanted to pick up your calculator and put it in your calculator, you can. That's approximately negative 0.011 meters per minute. Either one is fine. But what did they ask us to find? They asked us to find how fast is the water level falling. Now, if we had a positive answer, we would know we were incorrect because in order to be the water level to be falling, the dH dt has to be negative. So the water level is falling at, now you're either going to put your 8 over 225 pi, and notice it's positive, meters per minute, or you're going to put 0.011 meters per minute. You don't have to put them both, just whichever one you are putting. And this is the answer to your question. All right. Now, there's a part B. How fast is the radius of the water surface changing at that same moment? So it's the same moment in time. This time we're looking for dr dt when h equals 5 centimeters. Now remember, our volume is pi over 3 r squared h. If we're going to take this derivative, we need to use the product rule. So the derivative of v is dv dt. Now on the right-hand side, it's a product rule. So if we take the derivative of pi over 3r squared, we're going to have 2 pi over 3 r to the first times dr dt, and don't forget to keep the h, plus, now we're going to keep the pi over 3 r squared times the derivative of the h is dh dt. Now all the values we had in the previous part get to follow through here because we're at the same moment. We're using that same moment. So dv dt is negative 50 equals 2 pi over 3. Uh-oh. I don't know what r is. Let's go back. Remember, we found earlier this ratio, right? That r over h equals 15 over 2. So r over h equals 15 over 2, which means that r was 15 halves times whatever h is. And we know that h, in this case, is 5. So 15 times 5 is 75 over 2 is the r for this part of the problem. So I'm going to put in that 75 over 2. H is 5. dr dt is what we're looking for. Plus pi over 3 times r is 75 over 2 squared times, we found that dh dt was negative 8, and I would not use the negative 0.011 here. You cannot use a rounded answer in this part of the problem. Negative 8 over 225 pi. Okay, so now I'm going to have negative 50 equals. Now if I look at this, let's see. This 2 is going to cancel with this one. 3 is going to 75 25 times. So I've got 25 times 5 is 125 pi dr dt. Okay. And then over here, I'm going to have, notice the pi's are going to cancel. That's nice. Okay, so if we use our calculator and we put all that in there, now that the pi's are gone, we should get minus 50 over 3. Check it if you don't. Now we're going to add 50 thirds. So that's negative 150 thirds. So that's going to give on top, right? This part is negative 150 over 3. So if I add 50, I get negative 100 thirds equals 125 pi dr dt, which means if I divide both sides by 125 pi, I'm going to have negative 100 over 3 times 125 pi, which is going to reduce to negative 4 over 15 pi, right? Because 25 goes into this negative 4 times, and 25 goes into this 5 times, and 3 times 5 is your 15. And our unit on this is meters per minute. So this is how fast the radius is changing. If you want to put it in your calculator, you can do that. It's approximately negative 0.085 meters per minute. Now, before we go, I want to say we did the derivative of this using the product rule. When we did this one in the last problem, we took the r out and replaced it with h. We could do the same thing in this problem. We could use this ratio and find that h is 2 over 15 times r, and then the volume would be pi over 3 r squared times 2 over 15 r. And then when you take the derivative, you would not have to do the product rule. You just have this 2 pi over 45r cubed, and it might be easier for you to do the derivative. It will give you the same exact answer. Okay, guys, remember, related rates, you need to read the problem carefully, draw pictures, write down everything they tell you and everything you're looking for. I'll see you soon. Have a good one.